Our product entitled is Risk-Aware Query Replacement Approach for Secure Databases Performance Management. Next we move to abstract. Large amount of data and increase the demand to extract, analyze and derive knowledge from data are impairing nowadays performance of enterprise mission critical systems such as databases. For databases, the challenging problem is to manage complex and sometimes non-optimizing queries executed on enormous datasets stored across several tables. This generally results in increasing a query response time and loss of employee productivity. In this product, we investigated the problem of enterprise computing resource availability. Our goal is to minimize the performance degradations arising from resource-intensive queries. The proposed a risk-aware approach that decouples the process of the analyzing resource requirements of the SQL queries from their execution. Leverage of XACML to control the user's requests and to monitor database loads. This allows us to adjust available resource in a database system to computing resource needs of queries. A query can therefore run in a database if it does not severely impact the performance of database. Otherwise, we propose to the requester a replacement query denoted what if query. Such a query proposes results that are similar to the results of the requested query, is secure and provide an acceptable answer when it executed without compromising the performance of the database. Next we move to overall workflow about in that product. Start the process. A user submit a query. Next, PEP translate the query to equivalent XACML request. It finds the tables and columns the users can access from GMC. The next is the trim. The trim retrieved from the PEP policy applicable to the request. It also extracts some environmental attributes for using a performance prediction module, that is PPM. In this PPM determines the execution plans of the input query. Of these plans, PPM selects the optimal one and sends the cost and the wait time of the CPU of the system. In the processing the query to trim. The final process is the query adjustment module find the replacement query, which is what if query. It should input query if it case performance issues and sends it a trim, which then evaluate it and send it to PEP. Start the running process. It's an interior screen. The process was started. It's authentication process. In a risk-aware query replacement approach for secure database performance management, it's a user authentication process. It's a user substances and user substances verification panel. Credential ID. Select the query verification. There's a query certification process and certificate grant and select write credential ID again. Continue this process. Verification completed. Get the credential ID. Continue this process. Verification completed. This XACML process and the discover query replacement for database performance management is includes XACML retrieves as a database acquaintance, reuse the database successfully connected, and dataset attributes successfully. Next, monitoring the process. Monitoring XML process. It's monitoring the XML process and also data set will insert in program. Successfully, the monitor processing is changed. So what if query analysis extraction process? Check the process, get the particular result in the data set, and friends XML monitoring process and resource monitoring process. This is a XML processes. Screen. The transaction count, database load under the load, and find the risk band. The system performance, risk band in a UPS investment data, risk band needed time. This is a performance is called for action. This actions will be produced here. Actions performed. Next, formulation. Formulations are calculated here. So database loaded here, and they connected this and SP, RP, and PF. Hence, this PSP connected to the minimum similarity threshold and performance issues calls for action and risk band in edit time. So it's a deleted process. So I calculated from the every process in this particular AP process. Next is a trim process. Target evaluated module, security enforcement and performance monitoring. First, providing a EDP point, and again as provider. So employee ID, name, role, catalog, product. You can access this effects because of which only access for the admin. ACL, get this result, and ACM successfully updated. We get this result. And next, from ACM to ACM, we click this ACM, the answers and the target, subject, action, instances. Next, from this environment control access. Move to next. This is overall process to the and security enforcement performance. So every process done in there. This is a sum of rules and a regulation everything will evaluate and do. So move to next. This is a PPM process, the performance correction module in this database workflow. So find the database. It's a database workload. Analyze the workload. After analyzing the workload, resource requirement process. Character of the storage, reticator, halter, ensure of the control this process. We get this on the right answer. To next. The PPM process is a one of algorithm SQL query cost estimation. S1, C1, solve this problem. S2, C2, solve this problem. S3, completing the process. Still it's a process. After complete the process, we solve calculation completed. The answer is we get this problem solution. So first S1, S2, we get this solution, and S2, S3, you get the solution, and next S4. Calculated successfully. C4, calculate this, solve this problem, and C5, solve this problem, calculate this. Move to next. Specialization data bank association, activate database again, build the record again, store the data again, and store the complete data, providing some of datas, any datas, or providing any datas in this process. Inside that, select the database, any database, creator of the stores, authenticator, holder, find this, and definition 1, we find this solve this problems, and we get this, solve this problem, and click this, and we get definition 2, this, and solve this problems, we get this. And this is database storing the data as this. This is a sum of entire process, and finally we move to another. Find the term frequency and find the idea of inverse document frequency. Using this formula, we should find the TF into IDF. So overall, this process is much too familiar to access the query to document mapping. Document mapping to one process. Find the answers. Next, find the TF into IDF. It take a more brains because of it calculate the data. So find this. After frequency, go to next. SQL process. System resource availability is a cost estimating. Similarity cost estimating. It's a performance cost result. Calculating. Result is 0 because we have no access. Calculated successfully. The result was 0. We have no conclusion on this process. Wait time. Calculation was 0. So this cost estimate is have no values, and probability no values, and cost estimate values. Because of every process into system resource availability to control the particular process. So next, experimental results and similarity measurement. That's evaluation similarity measurement. This graph to users and weights the performance. Close this and risk band. Find the every users and evaluation similarity measurement, comparison cost, and threshold. This is another data set. Similarity scores. In this course, commenting the progress in S3 and the root algorithms find this entire process. So move to next. Monitoring process. Smoothly execute frequently, monitoring the memory process. Thank you. Our product entitled is